Welcome, everybody, to Continuous Testing Meetup. My name is Alex, and tonight we're having a next Continuous Testing Meetup with Benjamin. But first of all, we want to say thank you to TUI, Trendig, and Sauce Labs who are providing us the time and the opportunity to have these meetups. And also big thanks to Aurelian, who's being my co-moderator. And if you want to enjoy more of the continuous testing meetups, just go to continuoustestingmeetup.com. There you can see all the recordings from the previous times, and maybe you find something very interesting. Now we are proceeding to Benjamin, who's telling us about identifying code smells. Sounds very interesting. So it's
Yeah,
your stage.
thank you for having me. I hope it will be interesting. I'm doing my best to make it interesting. And I also have prepared some slides. What a surprise. Also, thanks for playing my requested song. I'm a huge reggae fan, so that sets me in the right mood for this a little heavier topic, I would say. But let's see how it goes. So, identify code smells. Let's dive right in. This is a requirement to have an About Me slide, I heard, so I have one too. My name is Benjamin. I'm a test automation engineer at Trivago in Germany, in Düsseldorf, Germany. And this is not a real subway station that I'm broadcasting from. It's actually one of Trivago's meeting rooms. I've been about 24 years in IT, um, the first 15 as a developer mostly, and the last 9 years I spent as a software development engineer in test. So I have this ongoing passion about code quality and software craftsmanship that also plays a role why I wanted to do this presentation. Yeah, very, very shameless plug. I wrote a book that has absolutely nothing to do with this topic. So if you're interested, check it out. But with this out of the way, um, another one that is between the content and the start. This is a little disclaimer. This is not about how to fix issues that you find with code smells, but it's more about identifying code smells. And I will also tell you why this might be a good idea. Also, I will show lots of code. It's all going to be in Java because this is the language I hate the least. Uh, yeah, I don't love any programming language. The programming language I really loved is not there anymore. It used to be ActionScript 3, but yeah, some of you might remember. But yeah, unfortunately, Flash Player is history. This is a slide for me, Smelly Code, Smelly Code. If you remember the original song, congratulations. If not, you're either too young or too old to know Friends, the TV show. The original was Smelly Cat. But like I said, this is just for me. I like this. But let's start now with the term cold smells. It actually came from this book, Refactoring, by Martin Fowler and Kent Beck. This is the first time this term actually appeared, and they defined it as a surface indication that usually corresponds to a deeper problem in the system. And this is crucial. A code smell is not necessarily a problem, but it can show you that there might be a problem. That is key. There doesn't have to be a problem, there might be a problem. So why should you care about code smells? So things that make you question the piece of code you're looking at, you feel like there's something wrong. But that helps when you can really identify what code smell this is. you can speak a common language. It's much nicer to say to another developer or tester, I found this particular code smell of this name in the code, than to say, I have the feeling something is off here. It's also a step towards better code. And if you combine it with clean code principles and design patterns and those things that come from software craftsmanship and maybe also extreme programming, that can help make your code better and ultimately to have less technical debt in your code, because this helps you to avoid problematic code early in the process. So not when something is completely done, you have a lot of technical debt that you have to tackle, but as soon as you look at the code first time, you can notice that something is off. And let's not forget, in the testing area, testable code is maintainable code, and maintainable code is testable code. So it's an ongoing loop that makes code better. And this also applies when you are talking to AI. When you write prompts, it's much better and gives you much better results if you can name code smells instead of just saying, tell me what's wrong with this. There was a little problem in the book. I would consider it a problem because I like uh, organization. So those code smells were more or less scattered throughout the book. And those two people here that I will not even dare to pronounce because they're from the Helsinki University of Technology. They wrote a paper about the taxonomy of code smells, and they actually created this table, this classification of code smells, and put them into categories. So it's easier to talk about them and to find them. And don't be scared, please. We will go through all of those 21 code smells. I hope we have 4 or 5 hours. No, I know we have 1 hour, so I'll be quick, promise. So let's start with the first category, which is called bloaters. And bloaters refer to something in the code that is too large to handle. And as you will see, this does not necessarily mean you have too much code, but it can be something more subtle. So this is how it will look like. I will show you some code, but I will help you to point out some lines that might be important here. And at the top of the slide, you will also see the name of the code smell. First one will be a long method. And if you look at this code, you might think, okay, this is not very long. This is quite a small method, but I will show you what I mean. So this method is called save customer, and it accepts a customer parameter. So far, so good. And also the first line just adds the customer to a list of existing customers. And this is exactly what you would expect from a method like this. But then there is something that is a little bit off here, because the return value of this method is a new string saying we have a new customer called, and then it inserts the customer name. So at first, this might not seem problematic, but it actually is a long method, because a long method refers to a method that does too much. So a save customer method, you would expect to just store the customer, but you wouldn't necessarily expect that it gives you this string back. And also, if you just see the method by itself, you might be thrown off by this return value and think, what is this? So you should always make sure that your methods do exactly one thing and one thing alone, and not surprise you with something else that's happening. This can also refer to a class. So on a class level, it's even more obvious. So this class is called shopping cart. Just imagine any web shop or e-commerce site, and you have methods here like add product, remove product, and checkout, which is all fine in this context. But here you also have the enter voucher code method that is more payment related and also a contact support method that has absolutely nothing to do with the shopping cart. So this is a class that does too much. Like the method that does too much, this is just a class that has too much responsibility, and it should ideally be split up. See, we already went through two code smells. We only have 19 to go. I hope this is okay for you, this path, this pace. If you think I'm going too fast or too slow, please tell me so I can adjust myself. But if there's no objection, I will go on with the primitive obsession. And this I see a lot. And also, I have to confess that I probably did all of these mistakes myself. So it's nothing that I point out and say, you shouldn't do this. I did this myself, all of this, probably. So here we have a customer, and the customer has a name, an age, street, city, country, all kind of valid. Well, maybe the age is something strange here, should be a date of birth, but the zip code is something that I want to point out here because it is saved as an integer, so as a number data type. And a zip code can be a string. It can contain letters in some countries. And also another problem here could be that the zip code could store a negative value in this case, or a zero, which is not valid. But there is no validation built into just the primitive type int, which is just a number. So here it might be better to have a custom class called zip code that also makes sure that all of those validations are built in. This is a classic, and this is something that we probably all have done. If you are developing code, you probably have done it. A method like this. It doesn't really matter what the context of this is. It's just an example method that is called calculate result, and it expects parameters like a base value, some Boolean values, is metric, is 2D, some kind of offset, and some kind of integer. And this might look fine at first, but if you call the method, it would look like this. Calculate result 13 false, true, -1 null. And if you look at this, you have no idea what those values actually mean. And also, you have this integer type, which in Java can also be null. That's why it is set to null in this example at the end. So that makes it even harder to test and is prone to errors. Also, this I point out as a tester, it is a nightmare to unit test something like this because of all those parameters and all those combinations, especially the Booleans that can be false, true, true, false in any combination. So a lot of things can go wrong, and it's really, really hard and confusing to use. And finally, the last one in the bloaters category is data clumps. That is when you group data together that should not be grouped together. Here's our old friend, the customer again. And this customer has a last name, a first name, a middle name, a salutation, which is all perfectly fine. And then there is also a street address and a city and a state and a country, which is not necessarily connected to the customer directly because a customer could have multiple addresses. There could be an address that has multiple customers. So this is a sign that this should be extracted out of this. And it's even more obvious with those two, like is employed or is homeowner. This is something that should definitely be separated from this, also because of legal reasons. If you retrieve a customer, not everybody should have access to those values, probably. So you should definitely think about what belongs together and what should be extracted out that you can then, of course, connect later again. One category is already done. Isn't that cool? So we have four more to go. Hope you're still with me. And then we can go to the object-oriented programming abuses. This is specific to object-oriented languages like Java. And this is when you don't use the object-oriented design possibilities that the language gives you. I have some examples again. Please don't judge the examples because some of them I know are really stupid, but I just made them up to point out specific things. Like this one is especially stupid, I have to confess. It's a method in the vehicles class called number of wheels. And this accepts a name of a vehicle and returns the number of wheels. So if it's a car, it returns four. If it's a boat, it returns zero. If it's a bike or a bicycle, I made sure of that, it returns two. And otherwise, it returns an exception. But this is branching out way too much because this is just handling something that the vehicles themselves should handle. Also, whenever you add a new vehicle, you have to add a new line here. So that can make it very, very messy to maintain. This one, temporary field, that is about fields in your class that are only used once. This was kind of tricky to find an example for, but I hope this makes sense. Also, this is an example that when you first look at it, you might think, I don't see anything wrong with that. This is a rectangle class, and in this rectangle class, you have a method called getAreaSize that just multiplies side A and side B of the rectangle to give you the area. But the problem is that this uses those two field values, so the side A and side B. And when you create a new rectangle, those sides are not set at all. So if you call the getAreaSize on a fresh rectangle, this will not work because it will give you zero all the time. So for this to work, you would have to create the rectangle, then call the set side A with the appropriate length, then set side B with the appropriate length, and then call the getAreaSize method. And if you do not document this thoroughly, nobody will do that. This is one of my favorite names of code smells. It's called refused bequest, and it's really bequest. It's not request. I looked it up. This is when you pass unneeded behavior to classes. And to illustrate that, I created this animal example. And because I learned from my mistakes before, I wanted to create an interface of an animal and require the method speak because in my world, all the animals could speak. So when you have a doc that implements the animal interface, it's of course required to implement the speak method. And the speak method just prints out woof. because this, I think, is what dogs do. And the problem comes when you have a fish, because a fish is quite silent. So what happens here is you implement this interface, you have to create this method, and this method is empty. And this is ugly. This is just behavior that you pass to your class and you say you have to implement this even though it is not needed. And that makes your code messy and can lead to a lot of confusion, especially if you have multiple interfaces that do this. So to fix this, just really quickly, maybe a good idea would be to have a speakable interface that you can also require for animals that can speak or make any sound. Number 4 in the OOP abuses category is different interfaces. This is an easy one, but I've seen this a lot. It's just confusing naming of functions that do similar things. And if you use PHP, especially the older versions of PHP, they have this problem, or at least they had this problem when I worked with this. So, simple example here, you have a shapes class, and in this there is a circle, and the circle has a get area size method that just calculates the area of the circle. And the rectangle also has a method like this, but in this case, it's get surface size and not get area size. And if you work with multiple classes that are kind of similar, and every class has an own naming of a method that does exactly the same, again, this leads to confusion, and you have to decide among the developers what would be a good name for all of them. Yeah, the time looks good. So uh, it's time for change preventers. And change preventers is a category that just hinders further development of the code, just has some kind of impediment, some kind of blocker that just you cannot make changes in the code as quickly as you want to. Like this one, which is called divergent change. This happens when you have to make changes across multiple methods in a class. For this, I created this animal information class because, yeah, you will notice I use a lot of animal examples, shape examples, and customer examples. I don't know where this came from, actually. So here the animal information class has a method that is called getLatinName. Again, you pass in a name of an animal, and then it gives you the Latin name for it. This has a similar problem like in the switch statement before, that it's branching out too much. But here it is an additional problem, because here I have a get number of legs method that also expects the name of an animal and then returns the number of legs. And in this case, whenever you add a new animal, you have to make changes to two methods. And this is easy to forget, especially when they're spread far apart in a class. You might add the animal to the one method and forget it in the second, and then you get unexpected results. And this is really, really problematic, but something very easy to fix too. Again, like the long class and long method example from the first category, this can apply to methods in different classes too. And then this has one of the most beautiful names I know in the code smells, which is called shotgun surgery. This applies when you have to make changes across classes. And you can just imagine someone with a shotgun shooting the solution, shooting the new code across the whole code base and hoping to hit all the classes that you have to change. So here I created a class called classification, which is also related to animals. And the getLatinName method is here. And I moved the getNumberOfLegs method in another class into the body parts class. And here you see the problem. We have the exact same situation as before, just that the methods are in different classes. So when you add an animal, you have to go to the classification class and the body parts class and make the changes there. Even worse. And the last one in the change preventers category is parallel hierarchy. And this is when you implement parallel interfaces. Frankly, this was one of the hardest examples to come up with, and also the hardest one to explain, I guess, but I'll try. So in this case, there is a bird class, and we have a sparrow that extends the bird. So far, so good. And we have an egg class. And we have the sparrow egg that extends the egg. So in this case, we have the bird and the sparrow that extends the bird, and we have an egg on the other side, and the sparrow egg, which extends the egg. So we have two parallel hierarchies. And when you now look at this lay egg method that returns a sparrow egg, this is where both come together. So that means if you have multiple birds, you have to make sure to have also multiple eggs. So you have parallel hierarchies, two trees that have to look exactly the same for both cases. I hope this makes sense. And I hope you also see why this might not be the best idea. Category number 4, dispensables. That is quite an easy category because it's just referring to unnecessary things in your code that can be removed. A classic is what's called lazy class. Again, I love those names that those code spells have. It's a class with a single method. So here's a web shop again. So I have the class web shop checkout. So again, I learned from my mistakes. I have something that is specific to the checkout in the web shop. And this class just has one method called checkout that gets the shopping cart and then something happens. Sorry, I was too quick. But what I wanted to point out is that this class has one method, and this is a sign that this is a lazy class and could probably be included in some other class. There are cases, of course, when this is desired. There are some design patterns where it is actually crucial that you have single class methods, like in let me think, the memento pattern. If you need something that has an undo functionality, it's always nicer to implement when you just have one class for everything that you can do. But in many cases, this can also point to problems and just have too much scattered code for limited functionality. A data class is a class that holds its data, but not the logic that belongs to this data. Again, this can be desired, of course. But in this case, I think it's not a good idea. Here I have a rectangle, and this rectangle, hooray, I learned, you pass it the side A and side B directly when you create the rectangle, which is cool. By the way, this is Java's record functionality. That is just a nicer way to define data classes. And this is how you create a rectangle. So you pass in the side A and side B, which is wonderful. So you have all the information that you need to calculate the area size. But here, this calculation of the area side uh, of the area is happening outside of the rectangle. So instead of asking the rectangle, what is your area size? This calculation happens here in the main method. This can be fine if this is the only place that you need this value, but if you use the rectangle in multiple places, you would have to implement this functionality in multiple places as well. A super classic thing is duplicate code. Like I said, if you have this example from before with the rectangle and the area size, and you do the same thing in multiple places, you have the same code multiple times. Like here, the customer list is back again, and here I use a for each to log all the customers in the add customer method. So I just get a list printed out of all the customers that are there. In the remove customer method, I do exactly the same. So to get a list printed out, I do a for each again and then print out all the customers. This is quite bad because, again, this is exactly the same code in two places. And if you want to change the whole thing to another logging system, maybe, or store those values somewhere else, you would have to re-implement this multiple times. So this is a good sign to put this somewhere else and and just use it once. That makes it way more easy to maintain. Dead code, this is fortunately something that modern IDEs also detect and point out, but not every time, depending on how you program. So in this case, a programmer uh, implemented a get pi method that returns the value of the mathematical constant pi. And then another developer pointed out, well, Java already has this built in. So now we switch this and use math.pi, which is the Java constant for pi. So that means that the get pi method is not used and can go away. Also, you might have noticed that this line that prints out returning pi comes after the return in the method. So this is now actually dead code inside of dead code. I I can't even imagine what to call it, like zombie code or something. And again, a very, very fancy name for a simple thing, speculative generality. Um, Premature future proofing, I would call it, or I will tell you later what I would call it, which is actually correct. But this just means that you're implementing stuff that you don't necessarily need right now. So here is an interface called printer with a print method and a turn on or off method that printers should implement. And here's a laser printer that implements this interface. So it has these functionalities of print and turn on or off. This is totally fine when you have multiple printers, but it might be too early to implement that when all you have is one single printer. So this adds complexity and effort that you don't need right now. And this also can make it a little bit harder to test and to understand Of course, it makes it easier in the future if you buy multiple new printers to have this, but it just prevents you from going forward in code that you actually need right now. So this might kill some of your time. This is also something that you can fight about with other developers very nicely because everyone has a different opinion on this. We are already in the last category. I hope you're still with me. I'm still eager to tell you about that. This is called couplers. This is all about coupling data, coupling classes, and if you have too much or too little. Feature envy is number 104. This is kind of what we had before in a different context. This is a class that implements features of another class. Here you have an address, a street, city, and country, which is nice. It's separated so you can reuse it. And inside of the user, you have a method that is called getAddressString that uses the value of the address to construct this string. And again, this is now on class level. This class user hijacks functionality and features of the address record, the address class that we have down there, because this should have the functionality to return itself as a string, like with the Java's toString method. Again, and again, with the definition of code smells that they might point to a problem, this can be desired. So with every code smell, you have to really discuss this and question, is this what we want? And it might be exactly what you need at that point. Love that name again, inappropriate intimacy. It is when classes know each other too well, when there is too much coupling between classes, like with books and authors. So here we have a book, and the book has an author. Already, you might sense that there's something off here. And this author has a book. And in this case, you have this kind of circular reference. You have an author that has a book, and this book has the author. And so it's just like an endless loop. Apart from the fact that a book can be written by multiple authors and one author can also write multiple books, this is something that is not necessary. Unless you have something like a database abstraction layer, which might require that. So you can actually search for books by authors and authors by books. But in that case, it should be lists anyways of authors and books. Just when you have this relationship that is two-sided, it might not be desired at that point. Message chains is something that I do regularly, even though I know I should know better, but I fall into that trap again and again. It's when you have objects that return other objects that return other objects. Sorry that this code looks a little bit more complex, but this is the thing I wanted to point out. Like in this case, we have a storehouse, and a storehouse has shelves, and shelves have products, and each product has a description. So if we want to get the description of the first product on the first shelf in the storehouse, we would do shelves.getZero.products.getZero.description. If there's anything wrong on the way, if you get a null value anywhere, the rest of the chain won't work and you will get an exception here. So chaining those things together can be really, really bad unless you're sure your data is consistent and doesn't have holes. And then last one is called middleman. This is when a class accesses another one on its behalf. So again, we have the address, and again, we have the customer. And in the customer, we have get city and get street. Again, that is functionality that is in the address already this time, because with address.getCity and address.street, you get exactly those values, but those are wrapped in extra methods in the customer. So from the customer, you can actually say customer.getCity, but in reality, this just asks the address that is inside it for the city. So it accesses the address on its behalf. It would be much nicer to say customer get address and then ask the address for the street and the city. So this is already it. This is all the categories, all the code smells in those categories. And of course, you don't have to memorize all these. There are lots of resources to look them up. But before I give you a link to sample code of all of those code smells, I want to quickly talk about when to tackle those, because this is also an important point. And there are some things that might be a good idea, and some things that might be worth knowing about. One is called the broken window. And this term refers to a house when a window is broken and this is not fixed for a long time. There will be other people that break other windows because it seems like, okay, this broken window, nobody cares about that, so I can break another one. And sooner or later, you will have garbage in the hallways and a lot more will be broken. So this refers to long-term effects of unfixed code. If you have a lot of technical debts in your code, you might not care as much about that code base because you say, there's so much wrong with it already, so I'll just slap some code on top of it and be done. Yagni, this is exactly the one that referred to the premature future proofing. Yagni stands for you ain't gonna need it. And this is one of my top mantras to code by. It's wasting time with future requirements. So if I don't need something right now to achieve something, I will avoid doing it. And yes, this is something that we can fight about. And I'm aware that other people might have another view on this, but I prefer doing the things that I have to do now first. And then when the new requirements come in, then I worry about them. The campground rule is another one that says always leave the campground cleaner than you found it. So when you see issues in the code, it might be a good way to just fix them quickly. Of course, you need those reviewed by other developers. You shouldn't just grab something and change it and say, I'm done. And this should also be covered by unit tests, at least. But as soon as you stumble across some code that you might think is off, you should at least start communicating about this and calling this out. And speaking of calling this out, code reviews are a very, very good place to call those code smells out and discuss them. Because there you see the code in context, and you're hopefully able to name the code smell you're detecting there. And then you can discuss this with other developers, and maybe you're missing some information about the context, and in the end, it turns out to be actually desired. But if it's not desired, then it's an easy way to fix it. And more information about code smells and how to actually tackle and fix them can be found in the refactoring.com page, which is the page that is by Martin Fowler that belongs to the refactoring book. And there you can see how you can tackle those code smells. Like on the right, you see examples like remove middlemen or combine functions into class. And this is a nice resource to see how potential fixes could be. Also, a nice resource is Refactoring Guru. This uses the same taxonomy, the same classification from this university paper, and that I also used in this presentation. So those code smells are actually really easy to locate. And then there is also a project on GitHub by Marcel Jerzig, who wrote a paper about actually fixing those code smells. And there's also a lot of information about that and some more examples. And of course, you can use AI. In this case, you give some code to Microsoft Copilot and you can ask which code smells can you identify, or you can say, I I have the feeling there is this code smell in my code, and then you can actually see, like here, the single responsibility principle violation. The save customer method is doing two things, saving the customer and creating a message. This is the example I gave it, and it actually pointed out exactly what's wrong with this. It called the code smell a little bit differently, but this can save a lot of time as well. And all of the example code I showed you is in my GitHub under Bischoff dev/code smells, code-smells. So you can take a look at that again. I can also send the links to you later if you want to have them. And here's my my song slide again for myself. And with that, thanks a lot for listening to me, and I hope you're still awake. I know it's a lot to take in, but I hope you you were bearing with me, and hopefully
I
you
had
learned a little bit. Thank you.
I, I had a question. Uh, I'm dealing with a team of automation engineers who are very new, like self-taught, you know, just scrapping it together to automate. What what should be my best approach? Like just go and dig through the code they're writing and look for these smells to see kind of who's um, more likely to use them and then like train in a presentation or like just directly go to that person and talk to them about their code.
Training is definitely a good idea in this regard. Um, it's oh, it's hard to say that without sounding condescending or so, but it I noticed a difference when you have a full development background and going into the automation direction. That can be harder when you come from a pure QA background going into automation because you don't really have that background. Me, myself, I might have a good background in coding principles, but I'm definitely lacking testing background. So I'm trying to learn more about that. But automation engineers should definitely also learn more about coding standards, design patterns, code smells, because this is part of our job, I think. And we also shouldn't be afraid to call those things out in a nice way, of course, because otherwise nothing will change. And I think it makes a lot of sense to have trainings as a group about those things. And also, I don't know what happens when when these automation engineers review their code, if they find issues with this, or if all have this mindset of slapping things together. This is kind of alarming. Unless this is something that is just a throwaway thing, just a one-time test that they need, and one-time problem that has to be solved today, and then it's thrown away. If it's something for long term, it needs to be maintainable. Otherwise, you just cannot go forward with the speed you need.
Yeah, it's definitely the the quality of the reviewer is variable. Like we don't have that just randomly sets someone to review. So you could get a developer who's doing the reviewing, but maybe they have no te context around testing, or you get somebody who has context around testing and can say this test is doing the right thing or the wrong thing, but nothing around the quality of the code. So I think training is the right way to go.
Yeah, and also more collaboration between testers and developers outside of um, their core job, because they should have some sort of collaboration so each one can learn from each other. That is very, very important, I think. I don't know, are there any more questions?
Yeah, I have two questions. One is, of course, knowing the theory of bad smells is super important. But what would you suggest to introduce it to a team which isn't currently focused in the quality?
Um, Quality should always be a focus in in what we're doing. I mean, quality is a team effort, and
Let's say in code quality, more precisely. Team maybe could have results, but he's not focused in code quality. So features are working, code is tested,
Mhm.
but maybe code is messy and full
Yeah.
of bad smells.
Yeah, I mean, it will get worse and worse. The technical debt will pile up, and it happened to us too. We had parts of the code that were kind of messy, and if you just continue working with this and putting more stuff on top, uh, at one point you think, okay, I thought this would be done in 2 days, but now we need 2 weeks to implement this feature, because if we do something here, something breaks over there because the code quality is bad. And you, there is also a lot of tools that you can use, linters. You can use tools like SonarQube that point out those issues. You can have quality gates. You can have percentages of unit tests. So there are also technical things you can do. Also, when you have a good IDE, this will point out certain things. But I think the first step is just awareness of this, so education. And yeah, I know it can be hard to have people accept that this is important. And for me, this is super important. Also, little things like naming functions, naming variables can be super important. Instead of having a variable that's called ABC, maybe have the whole word written out. Because this doesn't make a difference in speed. I mean, not today, not anymore. We don't have memory limitations anymore. We don't have processor power limitations that we cannot use 8 characters instead of one. So just little things.
Thanks.
So are there any more questions?
Oh, I just realized I answered the, do you know of any tools that can detect code smells? Just in
Exactly.
answering the other question.
Or an implicit, so.
Yes.
All right. Then let me share again and say thank you for your time. Thank you for your knowledge and bring this topic of code smells a bit closer to everyone. Yeah, soon there will be the recording again, so you can also show it to your developers. They will like it.
Hopefully, yeah.
Again on continuoustestingmeetup.com. And next time we will are talking about debugging the testers day, common problems and powerful solutions. Yeah, let's see. Sounds also very interesting. But yeah, have a nice evening, I would say, for today. And enjoy time. Have a good night or a good day, whatever time it is at your site. Bye-bye.
Thanks, Forbes. See you next month.
Bye.